In the 1950s, scientist Francis Crick proposed a hypothesis called the adapter hypothesis, which explains the transitions of how DNA is coded into amino acid sequences. He probably chose this name because of the literal function of an adapter. Before we dive into this, let me tell a personal anecdote from last summer that could put this whole process into simpler terms. I visited France for the first time last summer, and I found out about a day before I left that I needed a new accessory for all the chargers for my electronic devices. The European outlet is 2 holes, and the European charger is 2 round prongs, while the American chargers have 2 flat prongs, and sometimes 3 prongs where 2 are flat and 1 is round. Either way, you cannot use a plug in France without an adapter. We can relate this to the way that Francis Crick described the protein synthesis in the adapter hypothesis. Protein synthesis starts in the ribosome. In the ribosome, there are several bonding sites to make proteins. The mRNA, or messenger RNA, is carrying information from its genetic code to proteins. So the mRNA has codons waiting to be paired with anticodons, which will come from the tRNA. tRNA is made up of polypeptide chains and have anticodons attached to them. We can connect this process to our literal adapter example. The European outlet would be the ribosome. The American plug would be an example of mRNA, while the prongs on this plug would be the codons. The EU adapter itself would be the tRNA. The side that fits the American plug would be full of anticodons, as it allows for a perfect fit. The side with the European prongs would be the polypeptide chains that are attached to the tRNA. If some event occurred where the tRNA was altered and not able to act as an adapter, then it would be like trying to plug the flat prongs into the round outlet. Eventually, the cell would die from the tRNA not being charged and not binding to any site inside the ribosome. And in the outlet example, the cell phone would die from not being charged.